About 6 months ago, I made a video about the craziest Rover ever built, the 500 horsepower racer, otherwise known as the Camel Car, and you guys really seemed to like that video. In the video, I also featured several other Rover P6 race cars, as well as another car from Australia, built by Phil. I found the car really interesting, so a chap called Josh very kindly did some video with Phil and sent me some great footage of the car to put together this video for all you guys to enjoy. A massive shout out to Phil, Max and Josh. Without them this video would not have been possible. So without further ado, I hope you enjoy the video.
Hello from Australia, this is my Rover I've built. I'll just run you through all the bits and bobs on it. As you can see, they're 8-inch mini lights. Up here, I think you guys thought we had McPherson's strut. The stuff you saw from the top is actually a strap to stop the top arm from falling down too far. It is standard, all basically the construction of the suspension is all standard, but with all new bushes, new link points, new bushes in here. They're Japanese 4-spot calipers that I just found at the wreckers. The discs are Rolls-Royce Silver Shadow. We've moved all the inner arms to get our suspension settings. We've plated them, gusseted them, strengthened them. The oil system is our design. It's the Giroda pump in here. The oil pumps run on the crankshaft, the same as an LS Chev. We bypass everything and put our Peterson oil pressure regulator on it with a gravel strainer there. We run it over into a cooler, and then over into the filter and then back into the motor. It seems the most successful way of doing it because the original oil pump, oil pressure regulator returns everything back onto the suction side of the pump, which is for racing or any high performance work is just useless. We've got an enlarged aluminium sump, holds about 9 litres. We have retained the original cast iron P6 P6B 3500S extractors, cast iron manifolds, and we've ground the guts out of the inside. The gearbox is a Borg Warner single rail, made in England and commonly available. The exhaust, they're Gonzo spiral flow mufflers, custom made. The rear sway bar is the front sway bar cut off with all links made up for it, adjustable. The differential is out of a Jaguar, which was available at all their in British Leyland spare parts at the time. All the rear suspension is standard Rover P6B to Dion tube. This is just a cover we've put over the bellows because it's the last one I've got. The new ones are rubbish. This is from about 1978, that one, so we're protecting it. Reprogrammed Coney shocks. The front ones are the Whitehead's original modified. We've retained the Rover Jaguar inboard calipers, and these here are vents to channel through the left-hand rear window some air to try and cool the whole show. I've tried to keep the front as Rover as I can, but because of the heat in Australia, I removed the grills and fitted that gauze just to stop everything from 9/16 bolts from flying up through the oil cooler and radiator assembly. Just to protect everything and get maximum airflow. The radiator and the oil cooler I exclusively use PWR racing because they're just, the quality is out of this world. We have put or aircraft riveted a intake into the manifold, through the actual bonnet to try and get cool air. If you have a look, we've also removed the front panel where the wipers were, just to try and get all the hot air out. We fabricate our own air cleaner elements up. It's a Holly 600 double pumper with MSD ignition. We have used a 1962 model Buick distributor because we can get the internals for a Chev and put them in to make it full CDI. The water pump is electric. The actual Rover motor we're using here is the latest model that I think they made. It was a cross bolt, and it was, I think the prefix on the casting number was LCR, which is right up to the last ones that they ever produced. I think you call it a 4-block. I'm not real sure. Maybe somebody can fill that in. That's a distributor out of a 1962 model Buick. We use that, like I said before, is because we can get all the internals for the MSD and convert it all over to CDI. We don't run a water pump. We run an electric water pump, which is down here, and that seems to be a good idea because we're just running out of room in the front of the engine. The actual tapper covers are the later model 4.64 litre. There we obviously weld up holes. We grind all the internals out of it so we can fit the roller rockers. The actual roller rockers, a Yellow Terror, Australian made, and they're called Ultra Race, something like that. They're full roller on the shafts and on the tips. We do have to modify them a fair bit because we use the double valve springs, non-interference fit. We use one-piece valves, heavy-duty stainless steel. They are the same size as the original ones. Well, there might be half a mil difference in them. We do that because otherwise, if you put bigger valves in them, you're going to start notching the top of the bores, and you get into a lot more interference problems. So we steered away from that and just left them standard. It's pretty well as big as you want to go, and with the performance we're getting out of it, I don't think it warrants putting bigger valves in for the 6250 revs we put it on. We don't go over 6250 with a rev limiter. We use inside. We use chrome multi adjustable, custom-made push rods. We use, in this particular motor, which I don't normally do, we've run solid lifters. They're Johnson EDM with the holes in the bottom of them to help lubricate between the face of the lifter and the camshaft. It is quite an aggressive camshaft, I must admit, but we've actually changed cams a few times because one of the cams we had way too much torque. It kept breaking loose. We went for the up end rather than the upper end of the rev range, rather than start trying to chunk out huge amounts of torque down low. The heads, which we will show you later, and the inlet manifold, Edelbrock, the heads are actually SD1 Rover because this was built a long while ago. We could still get them, and they seem to me to have more casting inside them. It has the provision for the inlets for the pipes to let the air pumps, when they were mucking around with that 27A emission controls in Australia. They don't have the actual holes in there. Thus, they still have the extra casting, which I think gives you that little bit more to play with or to grind out. as I said, the bottom end is the LCR, I think they call it, which is the last of the blocks where the liners don't fall out of them. We buy the pistons from Marl, and they're finished, but not to what we want. So we take all the flashing off the inside, and we take a little bit off the skirt. We put our own valve reliefs in, obviously, and lighten them up as much as we possibly can. We use the standard. The pistons are, as I said, a Marl, and they're hypoeutectic, and they seem to be hanging in there. They're pretty good. I like to run as long a skirt on them as I can possibly get for stability and ring seal. The top ring in this particular motor is we've machined it out. We put a 2mm top ring, nodular cast iron. We use the Napier second ring, which is a 1.75, and the 3-piece Repco 3X oil control ring, the 3-piece one. I think Repco first designed that many years ago in the early 60s. That's the bottom oil ring we use. The rods are standard 4.6 litre rods, the later model BMW, when BMW owned it. We grind them down from about 780, sand them down, lighten them, call it what you want, shot peen and hardened, resize them, and we get them down to 569 grams. The actual gudgeon pins, we've changed them over because they were very heavy, because they were for Marl pistons. They were just too heavy. And I put a good set of JW LS Chev gudgeon pins in it. We use the old style clearances on the big end and main bearings, which is, I like to run about 1.8 on the big ends and 2.2 to 2.3 on the mains, maybe 2.5. The exhaust manifolds are P6B Rover manuals, which were slightly larger on the inside. Plus we absolutely grind the guts out of them, and the cylinder heads and the air manifold, because nothing matches. And I think if you treat the engine as an air pump, you're going to achieve the things that you want. Just treat it like an air pump. Open all the ports out as far as you possibly can without grinding into oblivion. We use a phenolic spacer, a 600 double pumper Rover polycarby, which seems to work really well. I tried a 650 and it just bogged. Didn't produce the drivability as the normal type 600. So we went away from the 650 HP. I think that's pretty well. On the other video, we did explain the oiling system, so I won't bother going back over that again. I'll take you back down into the workshop, and we'll have a look at the cylinder heads that I have done and I am doing. This is the later model one out of the MAs and the cross bolts. The head over here is a SD1 Rover. We don't use those anymore, the SD1s. We've gone on back over to here because of just availability, and they're all in better condition, and they're just a better head and better cast as far as I'm concerned. As you can see by the exhaust ports, and the inlets are no different, we actually do an extensive port job to make them as big as we possibly can, and not run into problems with push rods or anything like that. But it seems to work, and the motors do go very, very well. As far as the combustion chamber is concerned, we try not to, we take all the sharp edges of it, obviously. We leave the valve sizes the same, as I indicated before. This one here had all the squish taken out of it, as you can see by the line on this one. we incorporate all the squish back in it. We had too much compression before at one stage there. These are the pistons that we're using. As I said, they're male. The gudgeon pin's heavy as. We changed that to a JWLS lightweight tool steel gudgeon. The top ring we take out to 2, the middle one's 175, and the bottom ring's 3mm, 3-piece Repco 3X. Now the top of the piston, as you can see, and we did consult and have a lot of conversations with Jack Brabham when he did all his, and he said he'd try and turn the combustion chamber into a heron head. Try and put as much of the combustion chamber inside the piston. This is a piston that's straight out of the box with the gudgeon pin and everything in it. We do put valve reliefs in the top of the piston with a tool we've got in situ. When we put the cylinder head on, we just cut them. We do take a bit more out here to get the compression where we want it. We leave the squish or the internal charge motion on here around the side as much as we can. We relieve the side here as much as we can to get the laminar flow. Jack said, concentrate on laminar flow, don't worry about swirl or tumble, just do laminar flow. That will get you where you want to go. During COVID, we sent the car back to Jenny Cray and we fitted a aircraft polycarbonate windscreen. We removed the front window and the rear window and saved 53 kilos, which from my shoulders up made a hell of a difference as far as the handling was concerned. We had to change a lot of things, sway bar settings and etc, etc. We also put air intakes at the top because of Australian summers. We replaced the rear window with polycarbonate. All these screws are aircraft, and we opened up the back window to let all the smells out. The fuel tank and the fuel filter, we use Bendix Cessna aircraft lift pumps, which gives us 4.5 psi. There's 2 of them. That's plenty good enough. We've never run out of fuel so far. The vent in the left-hand rear window is to cool the rear brakes, which, being inboard, they desperately need. Most things have been moved out of the hot engine compartment and been put inside the car. We run a Morosso oil accumulator, which is here, so we can pre-oil the motor before we start it to give it 40-50 pounds of oil pressure.